Hello friends and welcome at my channel. Today I would like to investigate the function f of x equals to 1 divided over, let's say, x squared plus 3. So this is a function which has no problems at 0 or wherever in the denominator, right? So since x squared plus 3 is always greater than 0, we're never having any kind of troubles in the denominator. So we just know that domain is x is whatever you want to have, right? Every real number. Number two, do we have a symmetry? Yes, we do. Obviously, f of minus x is 1 divided over minus x squared plus 3. This is just 1 divided over x squared plus 3, and this is f of x, so check. This is only one kind of symmetry that we're having here. Considering the y-axis, everything is fine. Number three, limits x towards plus or minus infinity. This case doesn't matter because of the symmetry. So obviously, if x squared is increasing to infinity, the whole stuff is going to 0. Number four, 0 points. We have none, right? Because the fraction is equal to 0, and the numerator can never be 0, the denominator isn't 0. Once again, only could cause troubles, but never could bring the whole fraction to 0. That means it's never fulfilled, so no 0 points. Extreme values, f prime of x. So basically we can rewrite it as x squared plus 3 to the power of minus 1, which is minus 1 times x squared plus 3 to the power of minus 2 times 2x. So we're going to get minus 2x divided over x squared plus 3 squared. All right, so where is this fraction equal to 0? Obviously at 0. And, well, let's do the second derivative. F second prime of x. We need to do this also for the points of inflection. Keep the minus in front. It's 2 times x squared plus 3 squared minus 2x times 2 x squared plus 3 times 2x, right, divided over x squared plus 3 to the power of 4. So what are we going to be doing? Let me write it here. Don't want to change the page because I will lose some information maybe. We are canceling. Makes it easier for us a bit, but not that much. So we're going to get 2x squared, minus in front, 2x squared plus 6 minus 8x squared divided over x squared plus 3 cubed. So we have a minus in front, minus 6x squared plus 6 divided over x squared plus 3 cubed. Can I do something? Well, I could at least get rid of the minus, right? This is just 6x squared minus 6 divided over x squared plus 3 cubed. All right, there we go. Okay, so this is the second derivative. What's happening at 0? I have second prime at 0. This is obviously minus 6 divided by 27, so it's a negative value. We have point of inflection at 0. So this point of inflection is at 0. Sorry, not point of inflection. I'm not telling you this. It was second derivative test. We are less than 0, so we have a max. My bad. It's a max with a 0, and if we put 0 for x, it's going to be a third. 0 and a third. Now, for the point of inflection, we need to put this one equal to 0. So number 6, I think, 6x squared minus 6 divided over x squared plus 3 cubed equals to 0. That means x squared equals to 1, and that means plus minus 1. You know what? Let's compute the third derivative maybe. It's a bit practice for you guys. I've done some in my life. So it's 12x times x squared plus 3 cubed. Important here is just not to, you know, expand the parentheses because you will never finish this stuff. You should simplify as far as you can, and then you can add the similar terms. Then minus 6x squared minus 6 times 3x squared plus 3 squared times 2x again, divided over x, it's x squared plus 3 to the power of 6 even now. Well, what's happening next? We are taking x squared plus 3 squared outside of the parentheses. We're going to get 12x times x squared plus 3. We are having minus 6x, 6x squared minus 6. I'm taking my time here. I close the parentheses, divided over x squared plus 3 divided still by 6, but I'm writing it as times 4 and squared, boom, bam. Easier, getting easier. Okay, 12x to the power of 4 plus 36x minus 36x cubed plus 36x squared. Sadly, I cannot simplify. I can't simplify because I made a mistake. That's nice to see your own mistakes and to admit them. It's not always working like that. Do I have more mistakes? Yeah, I do. 36 just x. All right. Enough mistakes for today. Try to make none further. So here, right? Okay. Minus 24x cubed plus 72x divided over x squared plus 3 to the power of 4. That's the third derivative. If we put 1 or minus 1, we will never get 0. So f third derivative at 1 is not 0. So we do have point of inflection. Let's go w, and if we put 1, that was our function f of x, just to remind you, was, and to remind myself, squared plus 3, so it's 1 and a quarter. And w1 and w2 is minus 1, and still a quarter because of the symmetry. Okay, let's plot the graph. With so many mistakes, it must be nice. All right, max 0 third, 1 and minus 1 and a quarter, we have points of inflection. And if we're going to plus infinity, we're decreasing, we're going low to 0, and to minus infinity, the same stuff. So easy breezy. This is a kind of bell-shaped curve from Gauss. And we'll deal with the bell-shaped curve sooner or later, maybe in a different playlist about statistics. Thank you for watching, and see you guys in the next video. Bye-bye.